I don't think anything. Yeah, yeah. Whoa. Huh. Right, I'm listening to you over Discord. I am not muted though, and I know that because if I unmute myself on YouTube, I can hear myself. I think you may be muted though. Yeah, I think that Matt is right about that. So thank you very much, Matt, for pointing that out. We otherwise could have gone a very long time like this. Okay. Yeah. I I mm, I I wonder if that's actually gonna help though. Are you using Ops? Because it may have an audio section. It may be using like the wrong drivers or the wrong audio interface. No, but my voice is, I'm pretty sure, being sent to YouTube through your system.
Um, Matt, please let me know if you can hear me now.
I can hear you.
Oh, okay.
I'm getting
So
echo
so
now.
you're
Yeah.
getting echo now. All right, great. Yes, that was actually turned out to be an OBS side problem, which should have been obvious to me actually. Given that OBS is the thing actually. I shouldn't say OBS. I said OBS earlier today, talking to someone from TTF, and they were like, "Do you mean OBS?" Um, I'm not. I may be the only person in the world who pronounces it
No,
OBS.
I call it Ops too.
Oh,
I call
okay.
it Ops too.
So maybe I got it from you. I don't know. But anyway, the point is, this was an OBS issue, as it turns out. Audio should be working now, I think. And if it isn't, please let me. If you're not hearing anything, well, yeah, then you wouldn't know that I said that. But I will. So I will just type this.
No, I'm pretty sure though because I could suddenly hear
Yeah.
echo from you and I couldn't before. So I have you muted again now, but like I had you unmuted and
Okay. So after that thrilling introduction, I will repeat what I was saying earlier, since apparently nobody heard me. Um, so basically, where we left things off last time is that we were doing mirroring, right? We're just about ready to actually rig a character with this. All the pieces are working. Now, I mean, we think all the pieces are working. Once we actually try to rig something, we'll probably discover some issue like you do, right? But generally speaking, things are working. But we do need a way of mirroring. And last time I did it the dumb way first. I did it using translated rotate values. And as I expected, this only works for things in world space. You would need to do it in a somewhat more complex way to make it work properly for mirroring across with things like the legs, for instance, where, they are under the guides in this case are under a rotated space. Of course, the space that the guides are under and how they control the underlying rig, these two things are not really related, right? The guides are just passing world space matrices through to the inputs of the various components. So the fact that the guides are under a rotated space makes absolutely no difference as far as how the system behaves. However, it does mean that the way that we were going about doing mirroring did not actually work. Matt Nepotin asks, there is a Discord. Well, me and Tagore, when we to explain why we were referring to Discord, when we're doing these streams together, we're just talking on Discord, and I'm streaming, but with my system audio to include Tagore's voice.
Right. I can't listen to him through YouTube because YouTube enforces a delay, I guess mainly to keep people from cheating in games. And maybe it's possible to turn that off, but there is latency. So I wouldn't hear what Raph was saying until after he said it. It would be hard for us to converse. So right. We connect to each other using a separate voice app.
Yeah, that's why we were discussing Discord in that case.
I will say this. We did set up at one point a Notional Pipe Discord. We have not made it public at this point, largely because we're a little bit concerned about the amount of moderation it might take. At some point, I think we may consider doing that, though, and attempt to build a little bit of Notional Pipe community. It's just that we've been really busy.
Yes.
And so it's hard for us to keep enough of an eye on it to feel secure about having one that's public at the moment.
Yep. So, here is what I sort of want to communicate actually about this mirroring stuff, which is essentially what I think of as being the proper way to do it. And this is actually something that, although it is a relatively minor part of this whole system, I am going to go into a little bit of detail about it, I think, because it's actually a set of ideas that is actually pretty close to my heart. And like a lot of other things we've done on Notional Pipe streams, we anticipate that probably some people watching this may be pretty experienced riggers. Some people watching this may be really, really new. And these concepts are the first time they're encountering them. So I'm going to try to not take too much time and not rant as much as I may perhaps sometimes do. But I do think I want to at least explain a little bit of what I'm doing and why I'm doing it. And that basically has to do with thinking about mirroring in terms of matrices rather than thinking about it in terms of translated rotate values. And I'm going to do a little demonstration doing that essentially with a locator. So for those who may not be too familiar with using matrices, or even what they are, actually, all right, because plenty of different people with different experience levels could be watching this stream, I'll very briefly explain what a matrix is, right? Matrices are actually how transforms in Maya are stored internally. Translated, rotate, and scale values just produce matrices. And what a matrix is essentially, well, 4 because you have translation as well, but three vectors. Vectors being like little arrows. And actually, it's pretty easy to visualize what a matrix is just by looking at the arrows that any transform is associated with. Let me get one that isn't already a bunch of lines. It'll make it a little easier to look at, I think. So if I
am manfully resisting the temptation to actually you, but I will continue resisting it.
I am actually oversimplifying this tremendously. But basically, if you think about this as each one of these little arrows, right? The everything about the transformation, not just rotation and scale, as these separate components that we think about when we look at a transform, with channels in the channel box, right? We think of these as being separate. Think about this. It's really just these 3 arrows, and what direction these arrows point is what actually, or how long they are in the case of scale, is what actually defines what this transform is doing. And it's basically all about where these arrows are pointing. So the nice thing about this is that it lets you think about things in a way that doesn't require concepts like rotate order. which is exactly the kind of concept that we would run up into and have to deal with and think about in terms of like, how are these rotations being applied? Because the real issue with mirroring here is basically all about rotation. Mirroring translation is always super simple no matter how you do it, right? Mirroring rotation is a huge pain. So here is how I'm going to basically set up, and I'm going to demonstrate it with a locator, right? I mean, we don't want to actually use a locator to do this because that would be very, very silly. But I think I can demonstrate the concept using a locator. So let's take something like the foot. Now, in some cases here, it actually doesn't even matter. Because, for instance, the knee, the guide can be translated, but the guide can't even be rotated, right? Because it's going to infer all of its rotation from the guides around it so that it's always correct. Only translation is available. In the case of, say, the foot, however, that has both translation and rotation. So that would be a good case for us to take a look at our method of mirroring and how that would work. So actually, let me just hide the components for a second. I am going to do a very simple version of this. So the first thing you do is to match the transforms. So that I just get something where it is equivalent to the, I'm getting the locator. I'm getting basically what the transformation of this thing that I want to mirror across is, right? And now, here's one thing to observe. Because we're thinking about these things in terms of matrices, we can look at the orientation of these things and just think about the directions that these arrows are pointing. Instead of thinking about the series of rotations that would add up to this transformation. You just think about, like, where are the arrows pointing, instead of thinking about what is essentially this process that Euler rotations do to come up with the actual orientation of your object, which requires a lot more thought. All we actually need to do is to say, what's the, this is maybe more, it's actually not that hard, but it is sometimes a little hard to think about. But all we really need to say is, okay, here's the direction that these arrows are pointing on this side, and here's the direction they're pointing in that side. What do we need to do to this transformation to make the arrows point in the right direction when it gets to this side? So I find that much easier to think about, right? So here is kind of what that ends up being. So the first thing we can do in order to get it over to the other side is we could actually flip it by literally flipping the space it's under. So the equivalent to doing that in the Maya UI would be that I group it and then I scale the group by -x, thereby putting it on the other side, and then unparent it, right? That's sort of the equivalent of like flipping it over to the other side by flipping it into a left-handed space. Now, we have something here that does have the correct orientation in a sense, but where the line, because of the fact that, as you can see, it is negatively scaled in one place, these lines, these arrows, the vectors that actually kind of make up your matrix, I'm kind of ignoring a bunch of the translate-related parts of it, for the moment, because that part's easy here. There's actually a lot of cool stuff about things you can do with translation with matrices, but it's not really relevant right now. Obviously, the arrows do not point in the same direction, right? Here we have, it's a little hard to see, actually, because these are red. It's a little hard to see the x-axis, for instance, but if I zoom in, the x-axis is pointing up, and in this case, the x-axis is, it's really hard to see, because they're both red. I'm just gonna move it aside for purpose. I mean, obviously this will no longer be accurately mirrored, but for purposes of figuring out the technique, red axis points up, red axis is pointing down, right? Z-axis is pointing in the right direction, but the y-axis is not. Because these are matrices and we truly want to think of them as being a bunch of little arrows and not as being like the product of rotation values, we can actually fix this really directly by doing that. Now we have something with the correct orientation that has been flipped, but the arrows are all pointing in the same direction. Now you may say, yes, except you have a negative scale in every direction. Note that the combination of a given scale and rotation in the conventional translate, rotate, scale way of looking at things, there are multiple possible sets of combined rotate and scale values that can result in the same matrix. because again, it's all about where these little arrows are pointing and not about what rotation actually means or what these sort of separate values do. So if I were to, for instance, select here, and here I'm going to use, a little bit more ad hoc Python, but Maya does not provide you a manual way of doing this, frankly. And I'm going to say the second item I selected, which I think is the thing, yeah. I'm going to set its matrix, and I'm going to get the matrix from the first one. This is PyMel's way of doing this, where you just have like set matrix and get matrix methods on your transforms. You can do the same thing with commands or OM2. It's just you do it a little differently. So I get the matrix. I also need to make sure, because this is parented, that I'm doing it in world space. Note that arrows are pointing in the correct directions. This has been correctly mirrored, and we will verify that in a moment. But there is no actual scale going on here. We can verify that by going and looking at the attribute editor. It's locked anyway, right? But even if it wasn't, you wouldn't get negative scale values there, even though you do have them on the locator. And that's actually something I think is kind of a neat, I don't know, way of observe. It makes it clear what the difference is here, right? Between the concepts that we deal with in terms of translate and rotate and scale values in general in rigging, and how these transforms are actually represented underneath, which actually doesn't really care about the differences between different combinations of translate of rotate and scale values. And as you can imagine, this makes mirroring this so much easier than if we had to like play around with a bunch of, which rotation value do we invert under which conditions. It gets really ugly. And here, let's verify that this is in fact working properly, right? I'm going to actually orient this thing. Because here, the orientation's like pretty much world anyway. It's not quite world. So it's sort of like, it's not actually the best case. But let's do the same process, but we're going to do it with something oriented a little differently. Right? So like clearly, that's going to be a different example. Unparent it so that we get its world space values. And then we are going to do the exact same thing. And it works perfectly. Once again, matrices and vectors make everything easy when it's hard if you're thinking about like Euler rotations. So I'm going to make a little function that's going to let me do that to any of these nodes, since we kind of need that before we can actually put them inside a character. Unfortunately, that is going to be a little ugly because, I don't know, some aspects of how Maya deals with matrices, not sort of like really deals with them, but in terms of like how it presents them to you as these like special classes and stuff, make it a little ugly. There's like two different kinds of matrix class and stuff. But we can probably make this work not too unreasonably. There's the M matrix and the M transformation matrix, right? They do two different things. Let's see. So thing number one, I'm actually going to, for purposes of what we're doing right now, I'm going to grab a couple of the matrices that I know I will need from the world. That is to say, because what I was doing there with parenting the thing, flipping it over using the parent, and then, flipping it, a couple of the scale values on it, that's actually the equivalent of taking a bunch of different matrices and multiplying them together. So I'm going to just, you could specify these in code, but it's kind of awkward to do. I am just going to grab them from the scene, like so. So I'm going to say, here's one. I want one that's just multiplied, scale x multiplies -1. And I'm going to say, keeping in mind that S1 for me, this is my little, thing that I sort of alias pa.selected to, is the first item in the selection. And I'm going to call that's going to be get matrix. Now what this means flip matrix actually is is, well, this is what a matrix looks like when you look at it as numbers, right? It's basically each one of these things is a vector. And then I'm going to do the invert matrix is going to be the one that I'm using to invert two of the arrow directions, as it were. All right. Note, by the way, that one of the ways you can know that this matrix has the equivalent of negative scale values is that one of the vectors is pointing along -1. Meaning it's the other way, right? Like +1 would be positive scale. Let's see. So now I should be able to do something like this. I'm going to make myself a function to pass these things into. What it is going to do is, and I'm probably going to get the order on this wrong, the first time, because that is the thing that always happens. I'm going to say guy.get matrix. I need to make sure it's in world space. All right. Yeah, I'm going to multiply that by flip matrix. But I'm going to multiply, I think this is going in the right direction. I'm going to multiply the invert matrix by it. I think that will work. And then what I want to do, yeah, I barely needed to make this its own function, actually. And of course, that also has to happen in world space. Let's see if this works. Actually, let me just do this so I can see it a little better. Oh, right. Well, you wouldn't have even have been able to tell in this case because it's already oriented differently. Wow. I did it the right order, the right way around, the first time. That never happens. Let's check to see if that also works in the opposite direction. Which it should, but let's test it. Wow. It did work the first time. I'm very impressed. So now we actually have a way of mirroring this. Now we can start putting it in a character. I have no idea why this ended up getting left in front of it. I must have when I brought this in, I must have had a prefix there. I mean, whatever. I'm not going to care about it right now. And let's start. This is our superhero dude. I just needed to grab a mesh from somewhere. Let's start putting this stuff where it needs to go. See, I actually want to make his pelvis maybe up here a little bit. This doesn't really, I get into the habit of just, kind of being careful about this stuff. But actually, in this case, with the componentized system, it matters a lot less than it normally would. Because I am free to make adjustments to it later on. One thing, by the way, that's really nice about this that wasn't true of the Senate Machine 3, um, is, and I think this is very impressive in terms of Maya behavior, right? So take a look at this. So on the one hand, we've got the mesh, which is just, geometry in the Maya scene, right? We've also got the guides, and the guides are not their custom shapes, right? But note that even though they draw on top of the mesh, they also draw on top of each other correctly in terms of their depth in the scene. This is hard to do.
So yeah, it's one of these things that isn't very impressive if you've never tried to do it, because you're just like, well, that's how it should work, isn't it? It actually turns out to be trickier than you might think in Maya, and to do it, we had to write like some custom HLSL shaders.
Yeah, that is exactly the sort of thing that you'd probably think is like, probably no big deal. It's not no big deal at all, right? It's actually really painful.
I mean, it's not that bad once you figure out how to do it. It's one of those things where you think there really ought to be a way of doing this that doesn't involve like writing custom shaders, and there isn't. Once you figure out, nope, just got to write a custom shader, it's doable. Although the way you have to do it is, in my opinion, a little bit of a hack, but it works.
Let's see. Now, one thing we may actually choose to do, and this would be very, very easy, right? In fact, actually, it's so easy, I'm actually going to kind of do it right now. Which is that we've got all of these, like, guides. Like, we've got Pinky all, we've got, ring all, and stuff. And that's fine if you want to be able to do this. But wouldn't it be nice to, like, move the whole thing? Well, yes, it would. And actually, this being the kind of flexibility, that's intended to be true of how we're doing these components, it's super easy to do. I can just group these things. Is just like the one case where I'm okay with moving pivots. What the? Oh, I see what's going on. It doesn't really get actually what's going on with the like, because there's no actual geometry here. It's getting the bounding box wrong. I'm gonna do this slightly differently. I'm gonna position something first. I'm just gonna make a locator. Basically what was happening there, like, because I realized what I said was probably confusing, is that when I told it to center the pivot, it didn't center it correctly because it doesn't have the geometry it would need in order to figure out the bounding box. I mean, there's no geometry, actually. It's not real meshes in the scene. And so it came up with an answer in some other fashion that is unclear as to why it did that, but it definitely wasn't the one that we wanted. So I'm just going to position a locator here. All right. Oh, right. Forgot that I did it that way. Well, that would also be easy to fix, but I'm just going to add an additional group for the moment, for demonstration purposes. Basically, I had locked the channels there, so of course when you parent them, they don't properly stay in place. But what I actually will probably do, oh, interesting. I see why that's happening. So this is actually benign. Like, it's just the lines that are getting double transformed. I knew we were going to encounter something weird, right? This is actually in all probability working perfectly fine if I turn on the components. Yeah, it is, right? However, when I set up the thing that gets the position of those things for the lines, I must not have properly done that based on world space, which was very silly of me. Because my guess is that if I just undo that, if I move any individual one of these, it's fine. Yeah, it is, right? It isn't, that'll be very quick to fix, but I just need to make sure that it is correctly pulling world space values and does not care anything about the other aspects of transforming this stuff. So that was kind of unfortunate, and I guess what I am actually going to do is I am just going to move them all at once. It'll be slightly more irritating, but it's not really a big deal. I knew there was going to be something like that, right? There might be more than one thing like that. We'll find out. But note that even though I got the lines a bit wrong and double transformation-y there, the actual component itself behaved completely normally, which is one of the things that you get out of this idea of like, well, we're just going to base everything on world space matrices, because it's a lot harder to screw it up, right? If you're doing that. Actually, you know, I'm actually going to ignore the fingers for now. Because we are doing this for demonstration purposes, and I don't really want to take, like, I don't know, tweaking every finger. I mean, obviously this wouldn't really take that long, but I kind of don't want to do it right this second. I may just leave the fingers out of it for the moment. Actually, you know, I think I'm going to switch to... sorry, I meant to switch the translate. Yeah, there we go. It's actually a little easier to do this in World, I think, this sort of thing, than object translation. Let's see. This is supposed to be more or less at the bottom of the foot, because that's where we want our overshoot to end, right? You don't want the bottom of the foot wiggling around, even a little bit inside. You don't want the bottom of the foot wiggling around because something changed with the ankle, you know. Is this right? Probably pretty close. And again, you know, we can always adjust it later. That is one of the nice things about this. That is really one of the purposes of this. There we go. Let's just make that be out a little bit. And now we have the ability to mirror all this stuff over. Actually, before I got to do the head. And also before I do this, just checking the components to make sure everything's gone where it's supposed to go. Oh, that's right. We still got to do this thing here, which we will, you know, to reset that, which we sort of discussed that last time, and why that was an issue. But other than that, everything is doing what it's supposed to do and lining up. Now, what this does tell us, by the way, taking a look at these components, is that we do have to be very careful of the placement of the knee, which is a pretty normal issue, right? So the issue that we're having there is that this knee's almost straight, and the direction of the pole vector kind of has to depend. And it's working pretty well for the arm because the arm's slightly bent, but the direction of the pole vector has to depend on essentially the triangle, the plane formed by the triangle of these 3 points. So that's how rotate plane IK works, right? And as a result, and this was something that maybe we want to add a little arrow to the guides or something like we did with TSM3 to make this a little clearer. You know, it's if it's almost straight, it can be very, very sensitive to the placement of that thing. Because it can really only go in the direction that is, I guess, geometrically required, you might say, by those 3 points. And how you orient them is never going to matter. How you position them is the only thing that does. Might slide this back a little bit, slide this up a little bit. All right. And I'm honestly taking more care for this than I really ought to be, frankly. Because we can always change it later. Interesting. It's not drawing on top in this case. I wonder if that has to do with... Oh, interesting. Huh. That's weird. In this case, the geometry is occluding the shapes. I guess we'll have to take a look at why that's happening. Right, so this is actually the neck. So that's going to like go down over there. And then I also should make these a little smaller. I'm not going to worry about it too much right now. Jaws, you know, like not just jaws, but also, well, actually jaw hinging is a whole actually kind of complicated topic. But, you know, one of the things that's easy to get wrong, right, is you kind of have this idea of the pivot of the head being like at the place where the neck and the head meet, and it's not. It's like way up where the jaw is. The actual jaw pivot actually usually should be back like inside the further towards the back of the head than it pivots in actual anatomy, because actually the jaw is not a hinge joint in actual anatomy. It slides. And so the best way to deal with that is actually to put the jaw pivot like further back, but we don't have a jaw right now, so it doesn't matter. I'm just pointing out that I got to put this thing up here. And of course, to plenty of people, this will be very old news, but, to some people it may not be. All right, let's mirror all this stuff over. Doing this in a copy so I can just save it. By the way, I will just note, as you may note here by the rounded edges of things, I am using Windows 11. I foolishly decided to update. Turns out Maya 2018 doesn't work in Windows 11, so that is why I'm using Maya 2022 for this demonstration. The actual files will have to always work with 2018 because we support that with Contour. I'm a little unpleased with whatever combination of Autodesk and Microsoft choices led to this scenario. All right, let's do this. Let's do these two. That did not work as anticipated. I wonder why. Because my guess is that if I did it with these two, it would. So there may be something about how I'm arranging this that isn't quite right. In fact, I'm pretty sure that is exactly what's going on. Yeah, that's proper. Right, that is correct. So here's what I expect is going on here. It's that these have the same orientation. Right. Unlike the things underneath them. This is actually fine. Because I would, in fact, like them to take on the proper mirrored orientation. And then I will simply transfer it over. Here, I'm going to make this a button. This should all work correctly. And I also need to figure out how I want to do this for multiple things at a time. I mean, one thing that mirroring the whole right or the whole left side is a thing that, you may want to do. And we may end up doing some sort of like little table of mirror, things that, defines that precisely. I don't know. We'll see. But this, at least if you do it in hierarchy order, actually, does it even matter? Yeah, it does actually matter for these ones that have hierarchies, but it doesn't matter for all of them, will in fact produce correct mirrored stuff. Yeah, let me just turn that stuff off for the moment. Okay, so ignoring the fingers for purposes of demonstration, here we have a set of probably appropriate positions for these things. Let's hide the guides because we don't care about them right now, and show the components. Oh, and let's ensure that we have let's see, we're looking. I want to make sure I'm looking at everything's radius indicator. Yeah, because it was turned off on the spine. So I did, when I added the guides, the guide appearances, like the guide shapes, I also went ahead and wired up some stuff to control the appearance of the actual controls, the NURB circles that we use for those. And what that means is that when we change, I thought this was like a useful way to do it. When we change the radius of the spline, where we change the radius of the contour, bone chain, we're also changing the radius of those controls. And that's probably about the right thing. Something like that. and we can take them, but we're not obligated to stick to that radius. But it's a good way of having a starting point, because you have to decide on the radius based on the mesh anyway. Might as well use that information in both cases. That's probably about right anyway. Let's see. Legs, yeah, I mean, that might be fine. I mean, we can always play with this stuff. But then these need to get reset. And to do that, I'm pretty sure all I need to do is to reset this chain right here. Let's see. Right. Which we can do with the API. Yeah, I think this is it. Now, let me just check on one thing really quick. Yep, that is totally fine. All right. I think, I don't know. I'll look it up in our actual docs. And here we want to reset binding, rebinding, and unbinding. It's reset bind. Note how they have popped into the position that they are supposed to be in. This is all stuff we dealt with last time. But it is sort of a necessary part of this process because of the fact that we need to reset the bind data in order to have these be in their correct positions. Let's see. Yeah, we're pretty much ready to do this now. I'm just gonna, again, I'm ignoring the fingers. Now is the time at which we discover if something is deeply screwed up, as is, could certainly not impossible. That could happen. And yeah, we got to get the feet too. I mean, we could add them later if we wanted to, but. I selected the wrong thing. Yeah, I selected a bone when I meant to select a bone CV. Sorry, not a CV, a joint socket. Here, let me just make this a little easier. All right, only joint sockets. Actually, here's what I can do. What am I saying? It's not PS. There we go. There's all the sockets in the scene. I'm just gonna select those and exclude the fingers. No, that did not do what I thought it was going to do. All right. I am just going to select them again by hand and just be careful not to select a bone by accident. Which may have happened with the feet. We'll see. Actually, I don't even care about the feet because that's part of a separate mesh. I'm going to do the torso mesh first. And it'll take a second. There we go. Right, this isn't that arm's in IK mode. What do you know? Weighting's messed up, obviously. But here we have a working system. 1 second. I just got to get. There we go. Just get my YouTube view back. Whoops. And with all of our working features that we have built in here. Yep, everything should operate properly. Except right there, which obviously is not operating properly. I'll have to take a look at that. Yeah, weights are all screwed up there too, of course. Did I not select those? Or something? Let's see what happened here. Oh, what am I doing? Oh. I didn't bind the pants is what I didn't do. Obviously, they don't even have a contour deformer right now. All right, well, let's take a look at what's going on with that. We'll take a look at what's going on with that shoulder in a second. I'm guessing this has something to do with the mirroring. But before I do that, I just want to check a couple of other things to make sure they're working properly. Oh, right, and let's take a look at how to make the controls look a little better. So there's a number of ways that one might do that, right? Because like in this case, this control's fine. But the other controls are buried, and we do not want them to be buried. So the way that this works with the controls and the way that I'm automatically sort of having them respond to the radius of the spline is that I basically have a like there's a circle, type thing, a make nerve circle node in here whose radius is being controlled. Now, one way that I could deal with this is just to, in this particular case, and this may be the right way to do it because I really do want users to be able to shape these things to be whatever they want, is that in a sense I'm making sort of a distinction here between the operation of the system and the, the appearance, right? Where you could add your own shape to this and make it look like whatever you wanted it to look like. That doesn't really affect the behavior of the system, so I'm really okay with users doing that. And that will include the ability, if the user chooses, to simply break this connection and decide to make it bigger. Except, of course, Maya decides that you can never interactively slide one that's actually bigger than 10 units radius for reasons. Reasons that are fairly unclear to me. Oh, right. I'm using IK right now. Let's switch this back to FK. There we go. Let's try the other. Let's do it to this one too. I think it's fine. Oh, I didn't hook this one up. That's got to go on the list of things that need to get fixed. No, 10 or 12 are both incorrect values. Let's try 25. It'll do for now. Well, that is all working. Well, all right, it's got IK right now. So here's one of the things I'm going to do. I'm going to turn off IK. And then check this one's behavior. Because of that weird flipping we were seeing, there's a variety of reasons that could have been happening. And so what I want to do is to say, is that actually caused by something IK related, or is that something caused by probably the direction of the chain? Right? Because all of these bones are supposed to be, but I could have screwed this up, pointing down the negative x-axis. And they are. And they seem to have pretty reasonable values. This one does not have a reasonable value. Uh-huh. I have discovered the problem. Clearly, I did something incorrect when I set up the mirroring on the arms. Now, here's where things are going to be really helpful, which is this is a problem that I can fix. I can go back and fix in the arm thing, at least because these have not been collapsed yet. So if I go to the reference editor and take a look at these references, there's a whole bunch of references, right? These are all still references at this stage. Now, when we, so for instance, when I'm doing this at TTF, when I'm using the componentized system I designed there, all of these references remain part of the rig during the whole life of a project. Now, they don't they are not there when you publish it for animators, because like many pipelines at TTF, we have a publish step, right? Where like you do, you keep a version of the rig in which things are still referenced, and there are a variety of other things that are not actually what you're pushing into the pipeline for animators. And then every time you make an alteration to that rig, there's a publish step which cleans things up, including importing all the references and fixing anything associated with that. Which, if you're at a studio and you have a system specifically designed to be used by that studio in that studio's pipeline, is not only a perfectly reasonable way to do things, it's a highly desirable way to do things, right? You always have that malleability. But we're trying to produce something that is sort of general purpose for the use of users. And as a result, we need to be careful about doing things that are going to trip people up in common use cases, right? So one example would be if we do have these things all be references when the user creates it and the user doesn't explicitly publish it, and because Contour being a general tool that might be used by users in all kinds of different contexts, there's no guarantee that they would in fact, that's what they would want to do. Or would remember to do, or would even know was an important thing to do, right? We really kind of can't do that. So that does mean that when this is released as part of Contour, it will probably be on importing the system itself. Well, I mean, I wouldn't say probably. We've already written that part. It does, right? It imports these instead of referencing them, which means that you do lose malleability at that point, right? You can't do what I'm about to do and go back and change the reference. Now, of course, by the time that happens, these kinds of problems that I'm seeing right now would all have been fixed, and things should be fine. But it does mean that there's a trade-off there, right? You are losing some level of malleability. But in this case, this means we can fix issues like this really easily. I'm going to switch back to IK, because that is going to, I think that showed the issue off a little bit better. If I go doing this, at some point, it's going to flip really hard. Yep. It's something or other is passing 180 degrees, right? And the reason for that is that part of how it is getting the correct values, I mean, you may note that the arms, I didn't do the arm mirroring stuff on stream. I actually did that quite some time ago. And by the time I streamed it, I'd actually kind of forgotten how it works, which is why you see me like fumbling around a bunch when I'm doing the finger on the stream. But clearly I screwed it up at some point and didn't notice, right? Happens all the time. And here's how you can tell that that's the case. Note this like next joint joint orient setting of things, and know how this is like nearly 180 degrees for the next joint orient. So, here's what's happening here, right? Contour, in order to produce the super nice twisting, let me just remind everyone how incredible all this twisting is that you get for free. Look at that. Oh wait, I think I need to swap this. Did I ever turn this to use, one moment. I guess I must have hidden that. Yeah, alright. Oh, it won't let me. Alright, that's another thing I'll have to go back and fix. That should always be inherit twist, right? But again, very easy for me to just jump back into that thing and fix it. So let me use this as an example instead, right? Here I can get this like perfect twisting. I'm actually going to, I mean, it's looking weird here in part because there's a little bit of spline overshoot and we're not using inherit twist, but twisting is, one of the things that Contour does, the very best. This looks a little weird because of the weights, the legs are affecting it, but we'll fix that in a second. But in order to do that, what it is doing is looking at transforms along the spline, right? You've got like, and figuring out what the correct twist values to calculate up the spline are using a technique called I'm gonna screw this up.
That's a funny name for a technique.
Yeah, I know. Rotation minimizing frames, but we always said it wrong, didn't we?
Actually, yeah, we had a tendency to call them MRFs. I don't know why. It's like the first time we started referring to them by an acronym, somebody got it wrong. Might have been me, might have been Brian, I'm not sure. And then it just stuck in our heads, MRFs. So we actually have a lot of stuff in our code that's like this and that MRF, this and that MRF. But of course it's RMF, rotation minimizing frames.
Anyway, the point is that what's going on there is it can only calculate that effectively if it's got sort of a clear, like if you have a bunch of transforms and they're, as they should be, as they're supposed to be, but clearly they aren't, right? They're forward vectors, right? In this case, X, that's the direction the bones are pointing down, are aligned, then you do this and you get very reasonable values that can be calculated by the minimizing frames. If you have X pointing in opposite directions, then you have a problem, because then it's like, what's the shortest path for that rotation? Well, like as you cross that pole of being exactly backwards, it's going to go around one way or it's going to go around the other way. Like there isn't, you end up with instability, which is exactly what we're seeing here, right? And what that means, and how you can tell this is you can be like, well, if this is saying that the next joint orient is 180 degrees from the one behind it, well, clearly something is wrong, right? There's no evident 180 degree, like this isn't bent backwards or something. So that's clear. It clearly can't be that, right? It can't be supposed to be that. Like something is incorrect about what these transforms are doing. Probably ultimately this one is doing the wrong thing in some fashion. I mean, we can find out what that is. And therefore all of the other things which are coming, and keeping in mind all of these are being set because of the componentized system, all of these things are being set from the guides that are ultimately filtering their information into the inputs, which are then driving the system. I mean, if you were to just mirror using Contour's mirror tool joints, you would never see this happen, right? This is a consequence of making sure that the componentized system passes its data through correctly, which in this particular case it's not, right? So let's go fix both of those things on the arms. That's going to be the next thing. But again, here's the really, really nice, we're starting to see that those really nice consequences. Ah, damn, I'm editing this with Maya 2022, aren't I? This is that whole issue with, like, I don't want to leave these files in a state where they're actually in a later version of Maya. I want to keep them in Maya 2018. But I can't do that right at the moment because I installed Windows 11 like an idiot. I guess I'll just duplicate it and then I'll go back and fix it later after I've downgraded myself back to Windows 10. Yeah, I'm just gonna duplicate this. I guess they're right. This is I'm gonna this is all gonna be temporary. Whatever. I mean, I'm literally going to delete this soon, so it just reproduce the same fix in 2018, so that's fine. Let's see. So thing number one, and this is just this is something I need to make sure to do. Gotta make sure that inherit twist is on. It always should be for shoulders. All right. When I locked the attribute, that shouldn't make the value go away. 1 second. Oh, sorry. All right, there we go. I had just unchecked it and then also unlocked it, I think. All right. So let's see why this is happening. I think we can pretty well verify that it is not happening on the left side. I think this is most likely the case. Yeah, it clearly isn't. There's no 180 degrees anywhere in here, right? And there shouldn't have been in the other case either, right? This is sort of following down the positive X direction pretty like consistently, and it's basically doing exactly what you'd expect. So now we've got to figure out why it isn't when it's on the other side. So let's do that. So I am going to let's see, that is placed on inputs. I'm going to switch this to right. Then I'm going to place all the guides. I'm going to invert the position of all the guides. Or I'll just move them. I am inclined to use ad hoc Python for this because it would be very convenient, but this will work too and possibly be less confusing to some people. I do want to keep it. All right. Also, let me not select joints. I do want to keep it to something that hopefully I don't use all the time, because I know people do find it a bit confusing. So this should be the equivalent, right? You know, we have all the things over on the right side, and we've flipped it to write mode. And what we should see at this point, if you know, it probably is now that's interesting. We are not seeing. Let's see. This actually may give me some indication of what's going on here, because here's one thing I note. That is not incorrect. Oh, I have a theory about what's causing this. Okay, let me just check something real quick. This may have been a really silly issue. I didn't delete the other file. I don't think I did. I just made an additional one. ARM's still there. I'm going to say don't save because I had that set to checking references when I loaded the file for some other reason. Yeah, I have a sneaking suspicion I actually know why this is happening, and it was very silly. Let me check if I'm right about this. If I'm not, I'll be a bit surprised, but not because I'm always right, because that is very much not true. No, this is set to right, not to left. Because what I had thought was we seemed to get the correct values when I had it set to right in its own file. So why would that be incorrect here? Well, maybe I actually had it set to left when it's on the right side. That would explain it. But that does not seem to be the case. Yeah, that is definitely set to right. And this is definitely wrong. Then it might have something to do with how I'm doing the guides. Oh, yes. I bet it does. I bet it does. Right. Right. Okay, here's what's going on, and this should be easy enough to fix, and it's something I really should have thought of before. The guides for when you're doing something where you're starting with something like a shoulder, right? You've got these 3 points. The orientation of the shoulder actually doesn't matter in terms of the guides, right? It doesn't even have one. It's only got translate values. And the reason for that is that it doesn't need one, right? You know, it always is going to get the correct orientation off these 3 points. And it needs to because of IK, right? It needs to basically have a situation in which these 3 points and the plane formed by them gives it its orientation. And that's all you need to ever figure out its orientation. This is not true of the shoulders. So something that is untrue of the legs, for instance, where, I mean, you do have this overshoot, but it's a slightly different thing. Here, you know, the orientation really doesn't matter at this point. But it does matter for the shoulders. Now, one of the things that is different about what I just did with the arms when I did my sort of test moving it over to the other side for test purposes in my fixed version is that I did not change the orientation of that joint, the guide, right, the shoulder guide. However, when I am mirroring these things, I certainly am changing the orientation of shoulder guides. And so that means probably that whatever it is I did to do the mirroring on the arm, I wasn't taking that into account because I hadn't done it in my test case, right? You know, a pretty common potential issue. Let's go take a look at what happens if I do that. So, right. Check this over to right. And actually what I am going to do to ensure that this does in fact do what I think it ought to do is that I am going to do a slightly different version of the let's see, a slightly different version of that script that I had written, the tiny little script that does the mirroring, that instead of mirroring onto another transform, mirrors onto itself, right? So why is my script, there it is. So I'm going to say flip guide. I mean, this is actually silly. I should. It's doing literally the same thing, just with a different. No, I actually can do it literally by just using mirror guide and passing it the same item, I think. Well, that did not work for this one. Probably because I did it happened in the wrong order. Because that one is actually parented to something. So if you give it a world space value, relative to its parent, but its parent hasn't been calculated yet, then you are not going to get a useful result. But that's fine. I can just fix it easily. So here we have, this one will have had its orientation. Oh, we don't even allow it to. Interesting. Interesting. Let me take a look at this. What's this doing? Still getting reasonable values in the next joint orient. Why is this different? Possibly having to do with the orientation of this thing. Yes, I could very much see that being the case. All right. Sure. Yeah, that'd do it. All right, 1 second. I'm just gonna undo that. So I want to include this one as one's being mirrored, as it in fact is in our example. And once again, I kind of forgot to do that properly. Or rather, I guess I'm applying it incorrectly in terms of its placement. All right. Anyway, doesn't matter. That's the direction this thing would actually go. And what is this saying? Yep, there we go. There we go. We found the issue. So, let me just think about this for a second. Because I'm looking at the, again, we're looking at sort of the lines. Oh, wait, I might have this in world. Yeah, that's not useful. And there we have our problem. Let me think about this for a second. Right, I'm guessing the reason why I did not have rotation values on this joint. Oh, I think I do perhaps see why I did things that way. Right, it's got to aim at the next thing in line. I chose to have that aim be something that is happening based on the parent space, right? Let's take a look at what the actual aim on Clavicle Guide is doing. I'm pretty sure I know. Yeah, it's object rotation up, and the object rotation that it is using is all. Yeah, that's what I would have expected, right? All, however... Oh, this is interesting. Yeah. And all is oriented... Oh, interesting. Okay, let me take a look at this, because here's sort of to give an idea of like what's what's going wrong here, right? all of these things ought to be lined up. If Z is pointing backwards on one of them, it should be pointing backwards on all of them. If Y is pointing down on all of them, it should be pointing backwards on down on all of them, etc. Now, note that in this case, Z is pointing backwards, X is pointing in, well, actually technically forwards, whatever, relative to world space. Y is pointing down, sure. In this one, we are absolutely not seeing that. It's totally screwed up. And the reason for that is actually because of this thing I did right here. And the reason why I did that at the time is because, so I'm swapping it around so that it is changing its aim vector, right? It's changing its, well, actually, it's not its aim vector, it's its up vector, right, of the aim to be negative, because if this thing were not also changing its transformation, if all was not also changing its transformation, then this would actually be the correct thing to do. Because what you would have is a case where if this maintained its orientation the same way that it was originally, without being flipped, without being mirrored, right, then you would want this thing's Z value, because in that case, this Z would be forward. You'd want this Z value to point in the opposite direction. Just as we need the X, the aim vector of the X, which it's aiming down X, so the -1 in X needs to be pointing negatively towards the next item, the next guide, because if it were not doing so, then it wouldn't line up with the chain being down -X as opposed to positive X, and therefore you wouldn't get the right combination of rotations to give you that nice thing where you can select things on, on both sides and sort of rotate them, in concert, right? Rotations would not be properly mirrored. So I think I see what's going on here now. Before I fix it, I'm just going to do a sanity check. I'm going to go back to standard biped. Why is it doing that? It is getting very confused about where these component files live. And I'm not sure why. Also not sure why it's... Alright, what the... Yeah, there we go. Alright. Who knows, right? But what I want to do here is just make sure that I have done it correctly such that rotations are being properly mirrored on the controls. Clearly they aren't, which is actually not very surprising given what we just saw on the shoulders. But are they on the other arms? They had better be. Whoops. Oh, right. This is on IK right now. Well, of course, they're not really. They're already on a... Here, let me just zero these out and then try it. Because they're in different orientations now anyway. Yes, that is correct, which is what I expected, aside from, obviously, the thing that just happened there. That is not correct. So this basically tells me that I'm correct about that. That the orientation of the shoulder is incorrect, but that the orientation of the other elements of the arm is in fact correct. So let me just go back to where I was. And I believe this is actually going to be rather easy, the fix. Because this isn't actually necessary. I had basically done something that I thought was correct, but that turned out to not, in fact, be correct. And it may be as simple as this. Should always be 1. Because this thing is going to get its orientation lined up properly anyway, which I was not anticipating earlier. So we've got to make sure they're all lined up. They are all lined up. Does this mean that this has... That looks correct. That does not have a 180-degree twist in it anywhere. Now we are getting to having the problems probably solved, but let's check. So first of all, I'm going to reset sort of the base. I mean, the position of any of these guides, frankly, doesn't matter because it's always going to be overridden in the body, in the body plan file. It's always going to override the actual position of the guides. because the user needs to put them in some specific place, right? So I don't really care about that, but I do want this to default to left. And as long as I'm doing that, I might as well put things back on the left side. Which I can do here, and which is probably going to end up happening in the wrong order again, and it's going to be weird, but whatever. No, it didn't. I just forgot to select that thing entirely. Whatever. Here we go. All right. Now here is an example of the flexibility of the componentized system. Maya, you are doing some bizarre stuff right now. I do know why that happened, actually. I happen to know, because of some of the stuff we did with the ephemeral system, that every time Maya closes a file, it actually, I think, inits a new scene, a blank one, before it loads the next. And I think what was going on there is that it was momentarily confused, thinking it was loading a new file, and asked me to check the references. Let me just make sure these are all correct. Yeah, they are. This was just Maya being bizarre. Oh, this wasn't even the standard biped I wanted to open. I wanted to open the one, the alternate one that I made of the desktop. And that's why I can't find the ARM for some reason. All right. So here is the a thing you can do with the componentized system. Now, in this particular case, I would have otherwise gone and just fixed the ARM and then reloaded. But because I did not do that, because I was using Maya 2022, this actually simulates a thing that would be quite common to do with a componentized system, which is I want to have an alternate version of one of these components. Now, in this case, it was just to fix an issue, but it might have been to add additional functionality. It could change a variety of things about how the rig behaves. You could have different kinds of arms, right? And you can swap out these arms pretty transparently. So, although the fact that it's being used to bind a mesh may potentially make this more complicated, we'll see. We'll see if this works. In a very strict system, and our system is a little less strict than that, this would definitely work, even if you had bound it to a mesh. But in fact, as I hoped, that didn't present any issues. And this behavior shouldn't change. Like, this is all the same as it would have been otherwise. Oh, except I gotta fix one thing. So I think I did not actually save it the last time I did that. Yeah, that's what I thought. Yep. There we go. Better. All right. This immediately should, yep, there we go. Now we are getting something that is going to work much better in terms of shoulder deformation. So, this is all working as one would expect. I just wanted to verify that I hadn't broken anything. Now let's switch the other one. And this is going to mangle the mesh for a moment until we rebind. Right. So this completely mangles it because we have now changed what the default orientation of those things are, and therefore what its bind position would be. So let's reset all of this stuff to 0. Put it all back in bind pose. Because we're going to use rebind mode. Actually, we could have switched on rebind mode first and then done this. It doesn't really matter. Or we could do it using the API. It really shouldn't make much of a difference. This looks like bind pose. Here, it's an easy enough way for us to find out. Ignoring this shoulder stuff. If we turn off the deformer, does anything move? The answer is yes, but only because having switched this to use propagate twist will have changed that slightly. So if we were to go enter and exit rebind mode, like I said, I probably could have entered it first and then done this, but whatever. That'll reset the bind for all of these things. At this point, let's double check on this. Aha, that looks much more like what I would like to see, right? That is the orientation of things lining up properly. Now let's check the... Yeah, now everything is oriented correctly. I might like this much more. Ignoring this, obviously. That is not great. That is not great deformation, but it is purely a weight painting issue because this is contour, of course. This kind of deformation looks great. Deformation in between them we're going to have to do a little weight painting on, but at least it's less weight painting than you'd have to do otherwise. So that wrong axis. That's all working. That's all working. Here's another weight painting issue. All right. Yeah, I mean we are basically let's go fix that. Let's go fix those weights then. I guess. I think that's the next thing. I keep selecting this like literally decades of habit, right? You know. Obviously, that is not where you find the contour paint weight painting tool. Where are tools? Those are not tools. That's the attribute editor. Thank you. And this being contour, we can sort of blithely do stuff. Oh, this is the spoof tool. That's why it's not doing what I... There we go. We can sort of blithely do stuff that would otherwise probably be a bad idea because we can, you know, it won't end up with wacky values if you try to smooth stuff like this. You know, it'll just refuse to smooth things it can't smooth, that it can't normalize. Yeah, you probably couldn't see it. But down here, if I do this, it's telling me can't edit weights for vertex 2045. And I've probably mentioned this before on other streams. It's something I really, really like. Which is you do this with Maya, it'll try to do something, right? It'll try to figure out, because it can't normalize these weights. They're literally one, right? It'll try to figure that out. And it'll do a bad job. And it'll probably put weights in places that you didn't expect. And then they'll come and trip you up later. Contour just refuses to do it if it can't. Which is, in my view, by far the better possibility. And then you can just sort of, you know, blend some of this stuff in there if you want to. Now, what I had done for the contour man that we have on our site is, and I'm not going to do that right now, I did demonstrate it, I think, in a much earlier stream, is you can sort of do these, you can do some additional, you know, chains that you can use as kind of like a fake muscle, like not sim, or it's not muscle sim, right? But it's like, you know, muscle deformation sort of system that is really easy to implement. I'm not going to do that right now, but it is the kind of thing you'd often do with contour with a character like this. And that would be built on top. So if you were going to use the body plans to do that, you could perfectly well do that. You put a body plan in your character, then you stick some other, and that's the other really nice thing about it. Actually, maybe I should demonstrate that before, well, not that exact thing perhaps, but, you know, adding something to the rig before I sign off for today, which is that, any change you make, you can decide, I'm going to go and stick some additional ad hoc rigging that is specific to this character on top of my body plan generated rig, and then still change the proportions and not have an issue, right? Where, of course, the conventional idea is, you know, build your rig, and if you don't, and if you modify it in any way, you're screwed, right? Because you can't rebuild it now. The componentized system, and I've said this a bunch, but now we're really going to see it in practice, gets you around those issues completely. And, you know, you could probably, you know, do a bunch more work on this. I'm not going to try to, like, really make it too perfect. On the other hand, and, like, you know, again, it's not like we haven't made this point before, but it is an important point. While I did have to paint away some messed up stuff that we got from the auto weighting, um, we nevertheless got to the point of having a good looking thing at what is, from the point of view of any kind of conventional rigging, ludicrous speed, right? I had to fix some weights, which mainly involved, actually I gotta like fix some under here too, but still, like that was not very long for getting something that deforms like this. That was not long at all. Um, anyway, let me show you what I mean about the ability to add things to the rig and then still make guide based adjustments, which is a really important bit of what is possible in the context of using a componentized system. Um, yeah, I should really turn off mesh and bone selection so this stops tripping me up. I gotta go back to bind post when I do this. I probably should have made a button for this, which I could rather easily, but I have not actually done so. I think this should all be fine. Let's just check the spine for a second. All right, here's actually a quick way of checking. This should actually work accurately this time because we no longer have things that have changed since we last bound. And indeed, if I turn off the envelope on the deformer, nothing changes, so this is its bind pose. Yeah, let me just I don't know, I'm gonna throw like a cube on it. Like, let's say this was a character. Let's say this was like an armor piece or something else that you needed a special control for, right? So you have a control that you've perhaps, like, imagine this represents some other thing that something your character has to have. I'm going to buffer that control. I probably should have done that in the first place. And imagine it drives a cube. Right, so for purposes of argument, I'm just going to parent the cube. Like, in reality, you probably do something other than just parent it, but let's say that's what you needed to do, right? And I'm then going to deform field constrain. And I mean, you could do a variety of things. It does not actually have to be a deform field constraint per se. Yeah, I couldn't select that because I had turned off selection of joints. Where's my outliner? Right? Pretty normal thing to be doing with Contour, sticking something on there. But if I had been building this with an auto rig tool, even if it was an auto rig tool using Contour, you would now have a relationship between things that just wasn't represented in the auto rigger's description of what this rig was supposed to be at all. So if you want to rebuild anything, you're in trouble, right? On the other hand, I could enter rebind mode, go back to my guides, just hide the components for a moment so it's a little easier to select, go reposition these guides, because it's like, let's say I'm like, oh no, his arm needs to hinge over here, which is a ridiculous thing to do, but let's, for whatever reason, right? We're just making it as clear as possible, right? Remember that the components always follow along with the guides because data is flowing through the system, and that's how we've set it up. We leave rebind mode. Everything, it resets the bind. And look at that. We have now changed, we have completely changed the position of the elbow. But we have completely changed the position of the elbow and completely retained the ad hoc feature that we added to this rig. Now, I've sort of talked a lot about why this was important at various times through this stream in various contexts. But this is the first concrete demonstration of it, I think. Like,
yeah, this is super nifty. I mean, obviously having written some auto riggers, right? Which I have, I am looking at this and I'm definitely It is increasing my understanding of like what your objections to auto riggers are,
Yeah.
and about how this does get around a lot of these objections. This is very nice.
Yeah, and it's basically like, and this is such a, having used a different componentized system like in production very recently, the amount that it's just like, oh, now we sort of see like we should like the amount of, I mean, this is all right. A little bit of a rant. We actually should be done pretty soon, but I'm gonna do a little rant, right?
Tit.
Yeah. This is something that is true in rigging, but it's also true in many other aspects of production, right? We spend a tremendous amount of effort, perhaps even in some cases doubling our effort, to try to solve problems that we don't know we have yet, right? Because the consequences of you didn't solve it end up being really awful. Like an example would be, I mean, this is something I've been kind of dealing with a little bit recently, right? An example would be, you have people who are doing lighting, right? And then they are rendering out a bunch of different passes that are then going to be picked up by a compositing department to like completely finish up the shot, right? That is a very normal sort of pipeline. But it has these really awful consequences, which is you'd better be sure that the frames you get them are really what they need, because if you don't, you got to go back up the pipeline and make adjustments and then pass them the frames, a new set of frames. Now, of course, in like a really well-developed pipeline, that might not be the end of the world, right? In a really well-developed pipeline, that might be a relatively smooth process. But it's still a hitch, right? It's still like, oh, okay, I see I need this other thing. I've got to go to like some other department to get that thing, right? I've got to like go back to a different state of things in order to and probably explain to somebody else what it is that I need, right? It's like there's a lot of things about that in CG process, things where data kind of flows in one direction, and while efforts have been made to make it a little bit nicer, right, a little bit less onerous to go back up the pipeline, it's really still a problem, right? And this is a very similar thing. It's like, well, get your joint positions right, because if you have to change them in the future, I mean, this is actually significantly worse than the lighting and compositing example I was giving, which is, not great. But in the case of a rig, if you've done a lot of ad hoc work, which often ends up like in the press of production being necessary, then you can be in a really bad position. If it's like, oh, well, we've realized that the elbow isn't really in quite the right place.
It's funny. The parallels to programming here and to software development in general are extremely strong.
Yeah.
So much of developing software well is attempting to have a system that is flexible in circumstances like that, where that sort of thing bites you as little as possible.
Right. And for rigging, like very little work overall, honestly, has been put into the question of how to make that stuff not bite you, right? And that's not to say no work at all, because that's not really true at all. Like, certainly there are studios with very, very advanced auto rig systems. What they tend to do is to build everything through auto rigging, right? And if you're in a studio where you have a system that can really do that, fine. But actually accounting for all the things you may need to do is not an easy task at all. And it's much better if you don't have to, right? It's much better if you can be like, no, I mean, there's certain things that we need to make sure are completely repeatable. I mean, we need to make sure that we don't want to reinvent the wheel and make new arm rigs each time. Obviously, that would be horrific, right? All our arms should work the same way. But characters are not always the same, right? Characters have different requirements. Having to have a whole system that builds for all of those possible requirements is an extremely tall order, right? Much better if you simply can do an ad hoc thing if you need to, and it's no big deal. And that's really, I think, that and the ability to potentially swap components so you could have different kinds of arms, right? That's one of the really critical things that makes a componentized system superior to an auto rigging system. And you could, and we sort of mentioned this before, like you could theoretically make an auto rig system that worked like this, right? That sort of like was very careful about knowing how to strip itself out of the scene and then rehook itself up on the other side, right? Theoretically, you could do that, but it would be a real challenge. Like it's real.
That kind of stuff's hard. Yeah, that kind of stuff's hard.
So anyway, I think that's where I'm going to end it for today. But I think we've made some real progress here in that I kept saying, like, we're going to get to the point where we start making an actual character. Now we actually have, right?
Yeah. No, it's exciting.
And you know, we've seen, I mean, hopefully this is getting across to people. You know, like, I've gone now weeks and weeks and weeks being like, oh, we're sort of building this system, right? And sort of doing the work to build it up. Because and you know, arguably, I probably shouldn't have done that, actually. What I actually should have done is I should have started with just the arm or something and done, like, a character arm with it to show the benefits, right? I shouldn't have just charged ahead and made every single component. But that's not what I did. And now we are actually starting to see, like, why the hell am I doing this thing, right?
Sure.
And I think, you know, like, this is why I love this approach, right? It's the flexibility is so tremendous.
Okay.
Anyway.
All right. Well, thank you very much, Raph, and thank you everyone for stopping by, who stopped by, and for all of you who didn't stop by but are watching this later on. Thank you for watching. And as Raph usually says, but I'll say it today, please like and subscribe. It actually does help us quite a bit. The YouTube algorithm cares about this, so we'd certainly appreciate it.
Yep, and you know, we are you know, we'll be doing another you know, I'll be having one more stream, I think, on this, because, like, now we've gotten stuff working and everything seems to be correct. But we
are we streaming next week?
I think. Well, here's what I will say. I think we are probably streaming next week, yes. And so what I will be doing at that point, like, the next stream is just going to be like, all right, well, now let's finish the character, right? Like let's get it to the point where we've seen an entire character fully rigged with the system. And that really shouldn't be more than one more session, I don't think, because all of the things that were holding that back was, you know, I should have really expected this, right? You encounter issues, right? You find the places where you screwed things up. And because I'm only doing this in fits and starts of, like, an hour and a half a week, that ended up, like, that took what should have been, like, a very relatively small amount of work and ended up, like, stretching it out over a really long period of time. But the really sort of like now we have, I think, I mean, I'm not going to say we won't encounter some other issue, because we easily could, right? Who knows, right? But I think we've pretty much got things, you know, those issues squashed, and things should be in a position where really what we primarily just need to do is, yeah, I mean, you know, finish putting the legs and the fingers and stuff in there, and like, we'll have a fully, you know, working rig. And then after that, we'll sort of see. I mean, we've got a lot going on right now, and you know, we might move to streaming sort of on a different sort of schedule. I don't know. These are all things that we can discuss. But you know, we will see, like, we'll see where things go. But yeah, that's going to be the next one. And, you know, please be here for it. And basically, either it will be next week or something will come up and it'll be the week after, as has sometimes happened. You can find out. We will be announcing it on Twitter. And then, of course, on YouTube, if you have subscribed to our channel, which you should definitely do, you will get the alerts when I put up, like, you know, when I schedule the stream.
All right. Well, thank you very much. And thanks, everybody, for coming by. And we'll see you next time.
Yep. See you next time. All right. Bye.
Bye-bye.